plot, okay? And what we have is some agricultural students investigating the size of potatoes in 5 kilogram bags. They're investigating the hypothesis that the median mass of potatoes in a bag correlates with the number of potatoes in it. They weigh some potatoes and tabulate their results. So it doesn't specify what the x and the y axis is here, okay? So what we're going to do a scatter graph, okay? So if I wait a second. Here we go. So this here is a scatter graph of that data right there. Excuse me. This is a scatter graph of. 1 second. Oh, there we are. Right. Thank you. So this here is a scatter graph. Now, which axis did I use for which here? I used 0 to 60. I did the number of potatoes on the y-axis. For this question, it doesn't. So number of potatoes is the y-axis, and what's this one? The median weight, is it? Yeah. Median weight. Okay. Now, what you can see here is that there's a, what type of correlation are we looking at here? Positive or negative? I'd say it's a strong negative. Why is it a strong negative? Because if you imagine like a little cloud around the outside of the line, you can see that the cloud actually isn't that big. It just stretches about this much around the line, which is quite small. I say roughly, I'm going to keep guessing rough correlation coefficients to go with this. I give this roughly an R value of minus 0.8.
How do you come up with that?
Okay, it's roughly how close everything is. If everything was on the line perfectly, you'd be told that it's 1. So in a test, you'd be given a choice, okay? So here's the choices you'd be given. You'd be given, is it R equals 0.8, R equals 0.4, R equals minus 0.4, or R equals minus 0.8. You'd be given 4 choices and you'd be asked to tick one off. It's definitely not 0.4 because they're too close to the line to be 0.4. If it was 0.4, you'd have tons of them pretty far away from the line. It's definitely not a positive number. Why is it not a positive number? It's a negative correlation because it's going downwards, not upwards. So you'd be given choices, okay? Nobody can estimate a correlation exactly, but if you're given a choice of them, you'll know which one it is, okay? So that's the correlation coefficient. Now you have to explain what's the relationship. There is a strong negative correlation, okay? Now what other questions do we have here? Once this is done, I'll just drag this down here. And drag this down here. Now what else do I have to do? Draw the scatter diagram. Done. Which one of the following does the scatter diagram show? It shows a negative correlation. Explain your answer. Well, it's a negative slope. And you can see that the number of potatoes in a bag usually results in a smaller mean. Would you agree with that?
Yeah. Would for no correlation, does that mean it's going to be flat?
It means it's like this. It's almost like a square of data, and you have no idea which way to put the line. You could put the line in any direction, and you wouldn't know. Well, these ones, there's a general trend that the line goes through them all if it goes this way.
Ever be flat, like kind of in between negative and positive, kind of the.
Yeah, it'd be like a square of data. Like if I put in extra points like this. See the way I'm sort of squaring it out a bit? That means that one there would have no correlation. Because it's almost like a rectangle or a square. Okay? While other ones have a general, like a cloudy trend. If we look at the next one, we're told specifically age on the X and weight on the Y. Okay, so we're told that.
Did you miss one?
Okay guys, part 3. Draw the line of best, the students agreed to draw a line of best fit. Draw where you think they should put the line, alright? So I actually would have done that already. Just something like that. Okay. Part 4. From your line of best fit, estimate the number of potatoes in a bag with a median mass of 120. So I go down to 120, which is roughly here. Draw a line until it hits my line of best fit. If we're talking about a median mass of 120 potatoes, we roughly say there's 40. Do you get the whole point behind this question? When you give a stack of potatoes, it's 10 kilograms, yeah? But in some cases, you can either give them like, I don't know, 50 small potatoes, or you could give them like 25 or 30 large potatoes. The weights of all the bags are roughly the same. That's why if you get less potatoes, they're in general going to be heavier per potato. Well, if you get lots of potatoes, as in when do you have lots of potatoes? So 50 is the most potatoes somebody got in one bag. Somebody who got 50 potatoes in one bag, each potato only weighed 72 grams. But when you got only like 28, when you got 28 potatoes in one bag, the average weight was 192. Okay, so yeah, that's that question sorted. Now, find the average mean age of the coins. Okay, so I could technically do this by calculator, couldn't I? Anybody remember how to do this by calculator? You can do it separately where you add them all up together and you divide by how many of them there is. We'll just skip straight to that then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you get for the mean of the coins, lads?
42.3.
42.3, do everybody? You add them all up together and you divide by 10. So just add them all up together, divide by 10, and you should get 42.3. Did everybody get 42.3? What? Lads, you get 42.3 for that?
Yeah.
Okay. Then for the average weight, we just add them together. And what happens when we add them together? Add them together, divide by 10. 9.3. Yes, Sean.
I got 42.3 as well. The back of the book just says 42. Is that just a mistake?
Yeah, no, it's not. Just round it off.
Oh, right.
Okay. Now, that's what happens when you average them. What happens in general? The older the coin, is it the heavier it is? Is that the gist, or what is it? The older the coin, the lighter it is what it looks like. Is that right? The older the coin, the lighter it is. I can tell that from the data. Okay. Draw a scatter graph to represent this data. So I think I already have that done here. 1 second. What you do next is you draw your scatter diagram as shown. What we have is the weight is on the y-axis and the age is the x-axis. So, as an example, this point here, can anybody tell me what the red point is? It's you're 28 years old and your weight is 11.5. So that's 28, 11.5. That point represents. So, guys, this point here represents 28, age of 28, a mass of 11.5, okay? So, that's grand. Comment on the correlation. What correlation are we seeing here?
Negative.
We are seeing a negative correlation. Is it strong, or I think it's actually very strong. See how close the points are to the central line?
Yeah.
It's a very strong negative correlation. Okay, that's it. Plot the mean age and mean weight on XY. So what's the mean again? Was it 9.3 and what's the other point? 42.3. Now guys, can I say something? See the mean of both data sets. Your line of best fit should probably always go through this point. So 42.3 is around here, and what's a 9.3? I say it's that point there. That's roughly 42.3 and 9.3 right there. Okay, if you draw the line of best fit correctly. Draw the line of best fit through this point, and just draw it through that point. Okay, that's all they're asking you to do. Last question. Sorry, one other thing. Can anybody give me a rough correlation coefficient for this one? A rough value. Positive or negative?
Negative.
Okay, would 0.6 be a good one?
No.
Higher or lower?
Higher.
So, say an R value of maybe minus 0.9 or an R value of minus 0.8. Very strong, points are close to the line, it's negative.
When would it be a correlation of -1 if it was a perfect line?
If all the dots are on that line
Okay.
perfectly. Okay. Alright guys, last one. Thank God it's drawn for me. Okay.
So, I have a question about question 2.
What happens here is you're doing a scatter diagram of shows the amount of euros gambled on a fruit machine, and the amount of euro paid out. I think that's meant to say slot machine.
No, one of those slot machines that have to
Oh, okay,
yeah.
fruit slot machine. Okay, and the amount of the amount of euro paid out. So guys, what we can see is that the amount gambled, okay, the more you gamble, the more payout you get in general. Would you agree with that?
Yes.
Yeah.
So take this guy, he spent 16 euro. This guy spent 16 euro and he got a payout of 8 euro. He made an 8 euro loss. This guy spent roughly 19 euro and he got a payout of 5 euro. Okay, then the guys who spent, this guy spent 8 euro and won nothing. And then the next person spent 9 euro and won 1. So you can see in general, the more you gamble, eventually the machine's going to give you a token reward, but you ain't going to like double or triple your money. Hence the gambling business.
Never know.
Well, one person will, but they're in the minority. What was the greatest amount lost by any one gambler? I'd go for
19.
19 and 5. Is there anything else? 16 and 8. Yeah, it's got to be 19 and 5. What's this guy? Oh, 12 and 0. This 12 and 6 for this guy. Which one are you thinking?
17.
Where is it? Oh, there it is. Sorry, I didn't even see that point. One guy spent 17 euro and got 0 payout. 17 and 0 is the person who lost the most money.
No.
A new player decides to gamble 13 euro. How much do you think he'll get? So what we do is we go to 13 euro on our x-axis and we go across roughly 3 euro. Is that okay? 3 euro.
You're very anti-gambling.
Eamon has 5 euro to gamble. What could he reasonably expect his payout to be? He has 5 euro to gamble. So 5 euro, now that's an odd question because the line of best fit only goes back to 6 euro. You'd argue that he's going to get 0, nothing back. Because when you pay 5 euro, you're technically negative by the line of best fit. It's impossible to get negative payout. You either win nothing or you win some money. So you just say nothing in that case. Would you agree with that?
Yeah.
See the way it goes, see the way it crosses the x-axis, the y-axis becomes negative? That'd mean that you're going to get 0 payout. Okay, the machine can't physically reach out and take money from your pocket. Okay? Okay, Sean claims to have received a payout of 10 euro. Do you believe him? Justify your answer. I think Sean is full of lies because this one here, full of lies. Because this is a massive outlier. It's not beyond the realm of possibility that he got lucky, but it's highly unlikely.
Is that like